This video is about comparing and scaling problem 2.3, part 2, and it's going to cover the topic of proportional relationships. Let's first talk about what a proportional relationship is. The definition would be that a set of data represents a proportional relationship if you can multiply one variable by a constant number to get the value of the other variable. In other words, a data set would be proportional if the unit rate, or CROC, if it has a unit rate or a CROC and meets some other criteria. And if it is proportional, we're going to call the unit rate or the CROC the constant of proportionality. So that we have kind of interchangeable words depending on the situation: unit rate, CROC, or constant of proportionality in certain situations. There are a couple things we have to think about when we want to determine whether a set of data is proportional. And anytime we want to do this, we're going to ask ourselves two questions. First, the data set has to have a constant rate of change, or it has to have a CROC. And secondly, the starting value of the data set must be 0. So these are your two criteria for a data set being proportional. If the answers to both these questions are yes, then the data set is proportional. But if either of these questions has an answer of no, then the data set is not proportional. So we're going to look through now how we check to see if a set of data is proportional, whether we're looking at an equation, a table, or a graph. So let's start with equations. We're going to ask ourselves the same two questions every time. First question: does the equation have a constant rate of change? Okay. In the way we check this is we look to see if the independent variable, which is typically an x, is multiplied by a constant number with no exponents. So we have to have multiplication. It has to be a constant, and the exponent has to be 1, meaning that there's no exponent written there. If so, if we say yes to this, then we need to go on to the next question. Our data might be proportional. But if we say no, our data is not proportional, and we can stop our questioning right there. Our second question is to see, is the starting value 0? And when we look at an equation, the starting value is the value added to the end of the equation after the independent variable. If there's no starting value written, we assume it to be 0. So in that case, we would have a proportional relationship. If there is a starting value, meaning we're adding or subtracting something to the end of our equation, our data set would not be proportional. So here are 3 examples. Go through and determine whether or not each of these equations represents a proportional or not a proportional relationship. Okay, the first one, y equals 3x squared, is not proportional because I am not multiplying by a constant. I have an exponent of 2 there. The second one, y equals 3x plus 2, is not proportional. It has a constant rate of change, which would be 3, but the starting value in this case is not 0. It's actually 2, so it can't be proportional. The third one, y equals 3x, is proportional. I have a constant rate of change of 3. My starting value is 0 because remember, I don't need to write a plus 0 at the end of an equation. In this case, I would call the constant of proportionality 3 because that is my CROC. The next situation we're going to look at is determining whether a data set is proportional by looking at a table. We're going to ask ourselves the same two questions. Question 1, does the table have a constant rate of change? And we've already reviewed how to find a constant rate of change in a table. If the answer is yes, we move on. If the answer is no, we can stop. The data is not proportional. If it was yes, we move on to ask ourselves, is the starting value 0? In which case, we need to check one of two things. Can I put 0, 0 on the table? So you could extend your table to see if 0, 0 is on there. Or I need to check, does the constant rate of change match the unit rate? If the constant rate of change and the unit rate match, the data set is proportional. If they don't match, our data set is not proportional. So here are 3 examples. Go through and see if you can determine whether each of these tables represents a proportional relationship or not a proportional relationship. Okay, our first one here on the left is not going to be proportional. There is no constant rate of change. I'm increasing the y's by 6, 7, 8, so there's no constant rate of change. Our middle table is not proportional. I have a CROC. Every time x increases by 1, y is increasing by 3. However, if I were to put 0, make x 0, I would have to take 3 away from 4, and I would get that the point 0, 1 would be on here. So in this case, 0, 0 is not included, so this is not proportional. Another way to think about it is, I know the CROC is 3, but the value of 1, the x being 1, y is 4. So in this case, my unit rate is 4 and my CROC is 3, so they cannot be proportional. The third one here is proportional. I have a CROC of 5. The unit rate is also 5. If I were to take 1 away from x, I would have to take 5 away from y, and I would get x equals 0, y equals 0. In this case, I would call my constant of proportionality 5 because the CROC and the unit rate are both 5. Last thing we need to look at, the last situation we need to look at is determining whether a set of data is proportional by looking at its graph. We're going to ask the same two questions. First, does the graph have a constant rate of change? Remember our saying, if the line is straight, there is a constant rate. So all we're checking to see is whether or not the line is straight. If the answer is yes, we're going to move on to the next question. If the answer is no, our data is not proportional. Second question to ask ourselves, is the starting value 0? And to check that, all we need to look to see is if our graph goes through the origin, the coordinate point 0, 0. If the answer to this is yes, and we have a constant rate, then the data is proportional. If the answer to this is no, then the data is not proportional. Take a look at these three examples, and then continue on to check your answers. First one there on the left, that would not be proportional. The line is not straight, so there is no constant rate, therefore it's not proportional. One in the middle, we have a constant rate, but this time the starting value is not 0. It doesn't go through the origin, so that's not proportional. And the third one would be proportional. It's a straight line, means there's a constant rate of change, and the line goes through the origin, meaning the starting value is 0. So in summary, we learned in this video about proportional relationships. Remember, a proportional relationship is one where you can multiply the independent variable by a constant value. And in order to check to see whether anything is proportional, we need to meet two criteria. One, is there a constant rate of change? Two, does the starting value equal 0? We ask ourselves those questions. If the answer to both of those questions is yes, then the data is proportional. If the answer to either of those questions is no, then the data is not proportional.